In this module, we should look at how real-time protocol is used to transfer data, that is, audiovisual content, from the server to the client. And we're also going to look at the performance evaluation of it using the packet loss scenario. Specifically, we'll see how does RTP transfer data from the server to the client. We'll relate it to the important concepts of delay and jitter, because from the perspective of audiovisual communication, these concepts become very important. Then we'd look at the default built-in support for simulating real-time protocol from the INET community. And we'll see how have they provided means to evaluate the packet loss using this RTP scenario. Let's look at the family of real-time protocols. These protocols help us to access audiovisual content, whether stored or streaming, using either of the real-time protocol that works on top of the user datagram protocol at the transport layer, the real-time streaming protocol that works on top of TCP, real-time control protocol that controls the connection and the overall management of the transfer of audiovisual content. So, what is real-time protocol and how easily can we simulate it in Omnet++? RTP is a network protocol that delivers audio and video content over IP networks. It has a variety of applications such as IP telephony, streaming stored content, video conferencing, television on the internet, and push-to-talk service, which is widely used by the internet users. The relationship between the operation of RTP in real-world environment and its effects on the delay and jitter performances can be visualized and simulated by looking at a scenario that we have already discussed. This is a scenario in which there's a host PC that connects to a server through a multi-hop network. These are different points which are shown here at which the measurements can be done to determine the delay and the jitter. The INET community has put in a lot of good effort to simulate various scenarios. RTP is one of them. This URI shows the place from where you can also access the NED file for simulating RTP. Here you can see that it's a unicast scenario in which there's a server and there are 3 clients. Each of these clients, in a one-on-one unicast fashion, requests for content from the server, and the RTP server replies correspondingly. If you double-click on either of the hosts, the details of the compound modules within this host open up, and here you can see that RTP and RTCP are shown as other compound modules which are embedded within this NED file. The URI is also shown in here. If you keep on visiting the NED files, eventually you'll end up with the compound module details, for example, its gates, its parameters, and its controls. So if you're interested in determining the packet loss, you would see the use case diagram and the statistics support that the INET provides for these NED files. Here in this usage diagram, you see that RTP host actually builds upon the RTP, RTCP, the RTP application modules. Each of these modules in turn have their own distinct parameters, gates, and statistics. So if you're interested in determining the packet loss, you can measure that by doing the simulation run and extracting this using the event log from the drop packets. The drop packets actually tell you about the total number of packets which were dropped when this streaming took place from the server to the client.